So today we're going to finish up section 7.1, which of course is the beginning to our systems of linear equations unit. So as a quick review, we learned that a system of equations means when we have more than one equation together, usually using the same variables. Okay, so the first section is all about developing your own equation to use. We're going to get into solving them a little later, but I do want to finish up this section here. So it's just one more example that I want to go through that's going to be a little bit harder than the ones we've seen so far. So this one is going to be a question like so. Create a system of linear equations, because we're pretty much only going to deal with linear equations. To model this situation. All right, so a school raised $195 by collecting 3,000 recyclable items. And the school received 5 cents for each can. And 20 cents for each bottle. Okay. So what we're going to do is we'll set up a table first to kind of talk about what's happening here. So we'll say our cans are here, and what we'll do is we'll do dollar per item, and we'll do a number of items, and then we'll do dollars raised. The can and the bottle. Alright, so we know it's going to be 5 cents a can, we know it's going to be 20 cents a bottle. So for the number of items, we're not too sure, we don't know yet. Okay, we weren't explicitly told how much of each bottle and how much of each can we got. So we don't know, of those 3,000 items, how much was a can, or how many cans we had, how many bottles we had. So what we're going to do is we're going to pick some variables to represent the number of cans and the number of bottles. Okay, so we'll say C for cans, we'll say B for bottles, and we can use those variables with the information we already know to find out how much money we're going to get from those items, right? So we know the amount of money we get from cans is going to be 5 cents times how many cans. And likewise, it's going to be 20 cents times how many bottles we are recycling, right? So what we're going to do is we're going to put our total down here. So we know that this is going to be 3,000, and we know that this has to be 195. And what we have here essentially are our two equations that's going to make up our system. We have that piece of information there, and we have that piece of information there. So here what we're saying is whatever went in to those 3,000 items has to be made up of solely cans or bottles. So although we don't know exactly how many cans and how many bottles went in to, or that the school recycled, we know that whatever C is, whatever B is, when we add them together, they have to equal 3,000. We recycled 3,000 items. And we also know that however many cans we recycled, times that by 5 cents, add that to however many bottles we recycled, multiplied by 20 cents, has to add up to the amount of money that we raised. And the amount of money that we raised, of course, is $195. That's what we got from the question. Okay, so that's our system right there. So I'll just write it off to the side. Our system is C plus B equals 3,000 and 0.05 C plus 0.20 B equals 195. That's our system. Okay. We'll do the second half of this question, and that'll be all for this week. So what I'll say is the school got 2,700 cans and 300 bottles. And I'm going to say use this information to verify your system. Okay. So what we're saying here is that our C value is 2,700 and our B value is 300. And when we say to verify the system, we are looking to make sure that the left side equals the right side for both equations. Okay, for the system to be correct, all the equations in the system have to be satisfied. Okay, so we can check the first one. C plus B equals 3,000. So we can make our substitution there. So C, of course, is going to be 2,700. B is going to be the 300. And we're going to check if left side equals the right side. I think you can see already that it's going to. 2,700 plus 300, of course, is 3,000. So the left side equals the right side. So that's true. And the next one we can do is 0.05C plus 0.20B has to equal 195. This one you probably can't do in your head, but that's fine. The same value for B and C are going to go into this equation as well. So this actually ends up being 135 on that side. This side ends up being 60. And of course, we get 195 on both sides. So it's true. So we know that a possible combination for our original situation here, having 3,000 items totaling to $195, one possible combination is 2,700 cans and 300 bottles. Okay? So, yeah, that's pretty much it. I just wanted to go through this slightly more difficult example. Some questions lend themselves really nicely to setting up a table for yourself. So I'd recommend if you're having a tough time with one of the questions, see if you can set up a table, see if you can break it down. And if you're lucky, you can get one or more of your equations this way. Okay, so what we're going to do is we're going to finish up that assignment that started on page 401. So I got you guys to do up to question 7 last week. So we'll do, oops, so page 401. So we'll do question 8, we'll do question 9, we'll do question 11, and 17. And those are the ones that we're going to close out this section with. Okay, so next week we'll jump into section 4.2. We'll take the next step. But until then, stay safe out there, and I'll see you guys next time. Bye.